Okay. All right. So thanks for talking to me again, Donald. Hopefully we don't
Thank
have
you.
any
My
more
pleasure.
technical difficulties. So yeah, could you sort of explain a little bit about what you do?
So I'm a professor at the University of California at Irvine in the Cognitive Sciences Department, and I study visual perception using mathematical models and computational systems, simulations, studying how we see objects and colors and motion. I also look at the evolution of perception. What does natural selection entail about the verticality, the truth of our perceptions? And I'm very interested in trying to develop a mathematical model of consciousness. What is consciousness? Can we get a mathematical model of it that makes interesting predictions? So those are my areas of fun.
Okay. So you have sort of two parts to your theory, the interface theory of perception, and then the conscious, what would you call it? Conscious realism, I think you call it.
Mm-hmm.
Right.
Yes.
So could we talk a little bit about interface theory and what that really entails?
Right. So the question there is, do we see reality as it is? When we look around, we see the moon, we see everyday middle-sized objects like tables and chairs and spoons and apples and buses. And when we look inside the brain, we see microscopic objects like neurons. And the question is, do we see reality as it is when we're looking around? Do our senses show us the truth about the world? Now, no one expects that we see all of the truth, all of reality. But the question is, do we see the aspects of reality that we need? And by reality, I mean, just to say, for example, that a bus is real would mean that the bus would exist, would have its shape and color and so forth, even if there were no living creatures to observe it. So, and most of us would agree that, the moon presumably existed before there was ever life on Earth. And so it was real in the sense that it exists even if it's not perceived by any living creatures. So that's the sense in which I'm talking about real. And so most of us intuitively think that, of course, we're seeing reality as it is. When I see a bus, there really is a bus, and it really is objectively real in the sense that I just described. And, we all agree that we see a bus, and even if I don't see the bus, it can hit me and kill me. And then so same thing with the moon. Even if no creatures were observing the moon, it would still cause the tides on Earth. And so, we believe these things exist and are real, and that we're seeing truly something about them. We're seeing the true shape and color of the moon, the true craters and so forth. And one question is, why would we believe that? And for most scientists, the reason is evolution by natural selection. The idea is that our senses have been shaped by evolution to show us those aspects of reality that we need to survive. Of course, we don't see all of reality. That would be overwhelming, and we don't need it. But those aspects of reality that are critical to our fitness, we do perceive accurately. And so the idea in a nutshell is that accurate perceptions are fitter perceptions. They make you fitter. Those of our predecessors who saw more accurately had, a competitive advantage in the big tasks of life, feeding, fighting, fleeing, and mating. And because they did those a little bit better than those who saw less accurately, they were more likely to pass on their genes that coded for more accurate perceptions. And so our senses are really, according to this view, a window on the truth, a window on the world. We see a world of space-time and physical objects, and that's because there really is space-time and physical objects. It's a little bit more complicated, or a lot more complicated than what we literally see, but what we see is true. And to think otherwise is sort of faintly mad. Yeah, to say that the moon doesn't exist when no one looks is crazy, right? Or that neurons don't exist when they're not perceived.
It sounds very unusual to a lot of people, I think, doesn't it? But if you read any popular science books about quantum physics, Neil deGrasse Tyson, for example, they do say that that's pretty much how reality is, that what we see when we look at it like a particle or something is not really a particle when we're not looking. It's not, yeah.
Yeah, so yeah, that's been a bit of a confusion because the way things work or seem to work in the quantum world seem to be very, very different than our everyday classical perceptions of objects. And quantum physicists are still scratching their head to try to understand the relationship between the weird behavior in the quantum world and what seems to be very, very different behavior of objects in everyday life. We can talk in more detail about how to understand that relationship. But the issue of evolution is one that I've been looking at. And the question is it really true that evolution by natural selection would shape us to see objective reality, at least the parts of objective reality that would help us to be more fit? And so I, with my students, Justin Mark and Brian Marion, ran some evolutionary game simulations. It turns out that evolution by natural selection is not just a hand wave now. It's not just a vague idea. It's a mathematically precise science. We have the framework of evolutionary game theory and something called the replicator equation that we can use to actually pose precise questions and see in simulations and in theorems what natural selection would do. And so that's what we did first, was simulations. It's a little easier than proving theorems. And we created random worlds in which there were resources that organisms could go foraging for. And we placed creatures and artificial creatures in these worlds, some of which we let see the whole truth, and others that we didn't let them see any of the truth. We just let them understand or perceive fitness payoffs. And I should just say what I mean by fitness payoffs. You can actually think about evolution as like a video game. If you're playing a video game, in many cases, you're scrambling as fast as you can to grab points. And if you get enough points, you'll survive and get to the next level of the game. But if you lollygag around and do anything but grab points, you'll die. And it's the same in evolution. But the idea is that we're here, we're scrambling through life as quickly as we can to grab fitness payoffs. And if you get enough fitness payoffs, like enough good food, the right mates and things like that, if you get enough fitness payoffs, then you won't get to the next level of the game, but your offspring, your children, and which carry your genes, will make it to the next generation. And so the idea is that we're scrambling around for fitness payoffs, and if you do anything except focus on fitness payoffs, you're going to lose the game compared to a creature that's focused on the fitness payoffs. And so that's what we found in our evolutionary simulations, that artificial organisms that saw reality as it is, were never more fit than organisms of equal complexity that saw literally none of the reality in our simulations and were just chasing fitness payoffs. Their perceptions showed them fitness payoffs and showed nothing about the truth. And so it turned out seeing the truth made you extinct. Seeing none of the truth and just seeing fitness payoffs made you very, very fit. And so then I worked with a colleague, Chetan Prakash, who is a mathematician, and we now have a theorem, a couple theorems actually to this effect. And the theorem is, an organism that sees reality as it is never more fit than an organism of equal complexity that sees none of reality. So chasing reality is just playing the wrong game. It's like someone chasing pawns in the game of chess. You're going to lose to someone who's chasing the king because you're playing the wrong game. So chasing the truth is like chasing pawns. And chasing fitness payoffs is chasing the king. And so that's what evolution has shaped our senses to do, is to report fitness payoffs and not the truth. And so the question then becomes, well, seems counterintuitive. How can our perceptions be useful if they're not showing us the truth? And the metaphor I like to use is, think about the desktop interface on your computer. And suppose you're writing, an email or a book or something like that. And the icon for your file is, green and rectangular in the middle of your screen. Does that mean that the book or the email file itself in your computer is green and rectangular and in the middle of the computer? Well, clearly not. And anybody who thought that has a very naive view of the interface. It's not there to show you the truth, which in this metaphor is just the diodes and the circuits and software and voltages and magnetic fields. The interface is there to hide that truth in this metaphor. And it's there to give you simple symbols that will let you control the truth, control the circuits, even though you're utterly ignorant about those circuits and what they're doing. You may not know that they exist, you may disbelieve them, but you can still control them with the simple user interface. And that's what evolution has done for us. It's given us a user interface, not a window on truth, but a user interface. So it's crazy, but three-dimensional space, as you perceive it all around you, is just your three-dimensional desktop. And tables and chairs, the sun, moon, and neurons and so forth, these are just icons on your desktop that are there to hide the truth, but to let you interact with reality, whatever it might be, even though you're utterly ignorant about reality. So we didn't need to know the truth, and so evolution shaped us not to see the truth. It shaped us with simple symbols that were designed to keep us alive. So we have to take them seriously. If you see a snake, don't pick it up. If you see a cliff, don't jump off, and so forth. We have to take our symbols seriously, but that doesn't entitle us to take them literally. There are not literally snakes in space-time and buses and cliffs and so forth. Just like in your desktop, if you're playing Grand Theft Auto, there are not literally cars and steering wheels and so forth. That's all a nice virtual reality that you're using to interact with the circuits and software inside some supercomputer. But it's just a useful fiction. And that's what evolution has given us. Everything that we see is a useful fiction that lets us control the truth, to control reality, even though we're really ignorant about the nature of objective reality. So it's a stunning point of view.
So with your interface theory, it's sort of like the way that most people think that the world, or how the world appears to us to be, is that, we open our eyes and it's sort of like a window, curtains are open and you see what's out there, and then you close your eyes and whatever you saw that was out there, to you, you think that it's still there in exactly that form. So there's a box on my table here that's red. So I close my eyes and let's say the box is still there when I close my eyes, and it's still red and it's still square and all this stuff and still has the same textures and all that. So to most people, the world as it appears to them is the world that's there when no one's around, or when no one's conscious of it. When there's not a consciousness to be there, when there's not a nervous system that's interacting with that environment, the environment is exactly how it seems.
That's right.
Yeah.
That's what we normally think. That's our normal intuition. And it seems crazy to think otherwise.
Yeah. But then the neuroscientists come in. So we mentioned Anil Seth last time we spoke, didn't we? Mm-hmm. Anil Seth has this TED talk that's quite similar to yours in many ways, where he talks about the world that we experience isn't really the world that's there. We don't really open our eyes and just have complete access to the real world, because he's saying basically what's happening is your brain creates a hallucination, which then is modulated by inputs from the outside environment through light and other energy into your senses. And then your brain sort of predicts reality in this virtual model and creates sort of like a virtual reality inside your mind. And so then your brain is the generator of conscious experience and is the generator of this virtual model. So there is a world out there in that view that is very much like the model that's in your head. But the world that you experience is actually just the model, and that includes touch and taste and everything that you experience. But you take it a little bit further because you say, well, yes, all right, so there's a world out there, and the world that we experience isn't representative of that because it's a model. But not only is it a model, but the model itself bears absolutely no resemblance to what the real world is at all in any way. And that's where you come in and say, well, that's because the model that we're experiencing is a symbolic interface, so that we have basically ease of access to the real world, whatever that is, and are able to survive, because the real world would be too overwhelming if we didn't have this sort of symbolic interface. So so the objects around us are they do exist in some way, but not in the way that we see them or experience them in our consciousness. The coffee cup on my desk isn't really green or whatever. That's just a symbol of some underlying reality. So,
Right.
Is that a good summary, do you think, of what?
Right. Yeah, I think so. Anil says that our perceptions are a controlled hallucination, that in some sense we're seeing models that we've constructed, but he says that our hallucinations are controlled to match objective reality. So that, yes, I am hallucinating the bus, but I'm hallucinating the bus in a way that natural selection has shaped me such that it's controlled to pretty much match the true properties of the bus, at least those true properties that I need to survive. And so it's controlled hallucination controlled by the truth. And I'm saying it's fine to talk about controlled hallucination, but it's controlled not to represent anything about objective reality. It's controlled to represent fitness payoffs, the points that you need in the game of life to stay alive. And so when you see a physical object like an apple, that apple that you're perceiving is not some kind of photograph of a real apple. Instead, it's an abstract data structure. If you think about it in computer science, you have all these weird abstract data structures that we use in programming and so forth. Space itself is just your data structure. It's not, we think of space as the three-dimensional container or three-dimensional stage in which the drama of life plays out, and physical objects are real entities on that stage. And I'm saying that's utterly false. They're just data structures. Space is like some kind of data compressing, error correcting code that we use to represent fitness payoffs and the costs that we might incur to try to get fitness payoffs. The apple that's close to me in my representation would take less fitness costs to grab that apple and eat it than one that's further away. So space is coding fitness costs that I'll incur to get the payoffs of that apple close by versus one far away. And the apple itself is just a data structure. It's a solution to a complex computational problem. You've got all these fitness payoff functions that you have to obey in some sense to stay alive. And even, forget the truth, the complexity of all these fitness payoffs that are governing your survival is overwhelming. You can't even perceive all of that with accuracy, or you'd be overwhelmed by all the details. So what evolution has had to do is even simplify the fitness payoff structure into some little tiny symbolic format, some little structures that are actionable. And that's what physical objects are. They're a solution to a problem of telling you just those aspects of fitness payoffs that you need to stay alive and no more. So there's lots of fitness stuff out there that will eventually, be very important to us and will kill us because we don't know about it. But we don't know about it because, well, it won't kill us before we're grandparents. And so because it won't kill us before we're grandparents, it's just not going to be part of what we perceive. So cosmic radiation is flowing through our bodies all the time and ionizing stuff inside of us, and it'll eventually cause cancer and kill us. Well, yeah, it will. And most of us throughout human history have no idea that that's going on. We don't see it, even though it's going to kill us. And that's the idea, that fitness payoffs themselves are so complicated that we can't see them all. So physical objects are just a solution to an interesting computational problem. Just compress all this fitness stuff into the smallest necessary package that you can act on, and that's what objects are. They're data structures. And that's a completely radical way of thinking. And so, by the way, the data structures in a computer, right? You create a data structure, and when you don't need it, you garbage collect it. You throw it away to save memory. And that's what I'm saying is true of the apple. When I look at the apple, I create that data structure as a result of I'm representing fitness payoffs, compressed, simplified. And then as soon as I'm done with that, I look over here, I throw that data structure away. The apple ceases to exist because it only existed as a data structure of my perceptions. It has no other existence. There is a reality, so I'm not a solipsist. I'm not saying that there is no objective reality. But so there is some kind of objective reality. The language of space and time, of matter, of physical objects and shapes and colors, that language could not give a true description of objective reality. It's just the wrong language. Evolution shaped us with a language for fitness payoffs, and it's great language for that. It's the wrong language for objective reality.
Right. So you're saying you see an apple, and to you it's round and it's red and everything else, but that's just a data structure. So when you look away, when you say that data structure is destroyed or disposed of or whatever until you look at the apple again, what you're saying there is that that round red thing that you're calling an apple is a symbol that represents something, but it's not really there or here or anywhere, because the space and distance and everything that you're using to locate and see and perceive this thing is entirely just symbolic and in the interface of your mind that you're using to interact with reality with. And whatever the reality of the apple is, it's certainly not red and round and 3 feet away. It's
exactly
entirely different.
Like a green icon, a green rectangular icon in the middle of your screen it does mean that there's something green and rectangular and in the middle of your computer. I mean, it's just the wrong way to think about it. The interface is not there to show you the circuits and software, which is the reality there. It's there as just a guide to action, right? That's what the interface, it lets you control the circuits even though you're utterly ignorant about them. And the same thing with like Grand Theft Auto, right? So you see, you have a headset on and you're in a 3D virtual reality and you see a car and you see a black steering wheel. Well, I mean, there's no black steering wheel inside the supercomputer, and anybody who thought that is missing the whole point. And when you look where and see a steering wheel, you create the steering wheel, right? Clearly, there's no steering wheel. You're creating it when you see it. As soon as you turn your head and look somewhere else, you don't get the pixels being sprayed to your eye that would prompt you to create a headset. So you just that prompt you to create the steering wheel. So you destroy, when you look away, the steering wheel is gone. You've destroyed that data structure. Now I'm looking over here and I'm seeing say a Jaguar. So now I'm creating that data structure. Then I look back over here. Now I recreate the steering wheel. So we're creating these structures on the fly and destroying them on the fly. And that's what's happening all the time. So to make it totally clear how crazy this is, I create the sun when I look. I create the moon when I look. You create your sun, you create your moon when you look. The sun and moon did not exist before creatures were around to create them. Something exists, something not inside space and time, something probably far more complicated than we could imagine. And our species has a humble set of symbols like space and time, sun and moon. Those are the symbols we create when we interact with that other reality, whatever it might be. But then we just mistake our humble symbols as definitive statements about objective reality, and that's just it's a rookie mistake that we're making.
That really is a humble symbol, actually, for the sun, isn't it? It's literally just a yellow circle in the sky. That's it.
And a little bit of heat, right?
Yeah, yeah. One thing that you talked about a few minutes ago, I wanted to ask you about. So you were saying that not only so everything is a fitness payoff, and that's what you need to use these symbols for. So, like you have an object, and you were saying that you don't even see all the fitness payoffs for the single object because even that might be too overwhelming and too much to process. So you only see certain fitness payoffs at a time, maybe 2 or 3 or 4 at a time, rather than all of them. So that's kind of that's kind of even more crazy, isn't it? Because it's not only is everything just a symbolic interface, but even the symbolic interface is dumbed down and sort of filtered down into the most relevant fitness payoff icons.
Absolutely. That's right. So, and the very structure of objects, I've got a water bottle here that, the shape of this bottle is just a data structure that I'm creating, and it's telling me certain things about what this isn't a snake. I don't need to worry about it biting me. It's not a rock. If I throw it at somebody, it's probably not going to hurt them. It's just telling me how I can take certain actions, like how to grab it. I'm being told that there's water, I can drink it, and so forth. But as soon as I look away, that structure is gone. Now I see it. Now it's gone. And the idea is, from an evolutionary point of view, we have to do things. There are selection pressures. Do things as cheaply as possible. Every calorie that you spend on perception is a calorie that you have to go out, kill something, and eat it to get. And that thing probably wants to keep its calories, so it's going to fight you for those calories. The calories don't come easy. And so there are strong selection pressures from an evolutionary point of view for us to do things on the cheap. And so that's why we don't even have true perceptions of fitness payoffs. We don't have exhaustively true. We have dumbed down perceptions of fitness payoffs. And it's in really simplified data formats that just allow us to do what we need to do. So we don't see the truth, but we don't even see fitness payoffs that well. We just see, and we just, we think that we see the whole visual world in great detail, like 180 degrees, good detail. In fact, all that you see in high detail is roughly a disk which has a radius of about your thumb's width at arm's length. So your thumb's width at arm's length is about the radius of a disk, and that's all that little disk is all the high resolution you've got. What's happening is we're moving that thumb around, and I put it over there. Now I create a data structure of the fitness payoffs over there. Now I go over here, and there I see an apple. Over there I see a snake. Okay, so I've created that data structure. So I'm literally almost, what we do with the peripheral visual field is we're sort of scanning at low resolution about where we might need to create another important data structure about fitness. And there's something flickering over there. Better look over there and create a stronger data structure, a more detailed data structure about the fitness payoffs over there. So what's happening is we have this wide field of vision, which is just saying, okay, you probably need to look over there, which means you better create a more detailed data structure about fitness payoffs over there. And so that's what our eye movements are about. Our eye movements are about, now I'm going to create a data structure over there. Okay, now I'm going to throw that away. I'm not going to, I can't eat that. It won't kill me. Now let's look over here. Let's get it. So our eye movements are really, an indicator of creating and destroying fitness data structures all the time on the fly to do things as cheaply as possible. We don't want to keep stuff. And we're not creating a detailed data structure of the whole visual world. It would just be overwhelming. So we do things on the cheap. It's pretty, from this point of view, it's pretty stunning how little we know and how little we see.
Yeah, and I suppose whatever data structures we are seeing as well, they're sort of overlaid with our own sort of concepts of things too. So if you were in the jungle and there was a tiger or something like that, you need the icon of the tiger to be there. But like if you just saw the icon of the tiger or the visual experience of seeing a tiger and it was just empty of all meaning, then you wouldn't run away because it wouldn't be threatening. But you need these other layers that I guess what I'm trying to say is there's more to the interface. There's layers to the interface of conceptualization as well. That the tiger is a threat because of this, because of that, because of this. So run. Yeah.
Absolutely. So it's an interface designed for action. It's designed primarily to guide your actions so that you can stay alive and reproduce. And so some things are wired into us from birth. I still remember when my daughter was about 1 year old, and we brought a lobster home for dinner for the first time. It wasn't something we did very often. So we brought this lobster home for dinner, and she had never seen a lobster before, but she knew that she wasn't going to get anywhere near that thing. She didn't need to be trained. She just knew that lobsters were dangerous, and she stayed away. And so we are wired up by evolution to have certain innate reactions. We have innate fear of snakes and spiders and so forth. And in fact, that's why we have, when people get phobias, is to things like snakes and spiders and squirrels and so forth. We don't have phobias to guns or to SUVs, even though guns and SUVs kill more people now than snakes and spiders, at least in Western democracies, for example. And so we're wired up not for today. We're wired up for our evolutionary past, where snakes and spiders and so forth were more likely to kill us. And so that's what evolution is. It gives us symbols that guide our actions. It gives us, perceptions that guide our actions. And that's what it's about. And none of them resemble the truth. One way it might help people understand this is, if I ask you, take smell. The smell of vanilla, for example. What is it in our best theories that's going on in reality? Well, there's some molecule, the so-called vanillin molecule, and you can write it down as some chain of carbon and hydrogen and oxygen and other atoms. So think about this big molecular structure. And the question is, what would be the true, the veridical, the accurate way to smell that molecule? What is the objectively correct way to smell that molecule? Well, the question almost seems not to even make sense. It's sort of like, but molecules just don't have smells. I mean, the molecule is just our way of telling us that there's something that we need to do or not to do. Vanillin is great. I mean, we can eat that. That's perfectly fine. It's telling us it's safe, and it smells good as a way of telling us it's safe. But to say that that's the true smell, that seems crazy. Surely, we could imagine that a mouse might smell something different. And maybe, in the case of like chocolate or something like that, chocolate is great for humans. It can kill cats. You could imagine creatures that maybe chocolate is poisonous to, and maybe it smells bad to them. Or in the case of so-called coprophagic creatures that eat feces. Presumably, feces smell different to a fly than they do to a human. One should surely hope that they don't have the same revulsion that we have while they're eating. And so in the case of smells and molecules, it becomes very, very clear to us that the very idea that our perceptions are giving us the true smell of vanilla or the true smell of chocolate or the true taste of salt, it just doesn't, it's even hard for us to make sense of what that could mean. And all I'm saying is, what's obviously true for smells and tastes, I'm saying that's the same thing for sights. An apple is just like our smell of vanilla. It's not true, and the very idea of it being true is just silly. It's a rookie mistake. Just like thinking that vanilla is the right way to smell the molecule of vanilla. It's a rookie mistake. So but I'm saying that's true of space-time itself. Thinking of our perception of space-time as the true way to describe objective reality is just as flaky as saying that the smell of vanilla is the right way to represent the vanilla molecule. That's how far off we are. So if that helps, the vanilla molecule smell may be the best thing for people to focus on. Just realize that vision is like smell. It's no more accurate than smell is. But smell is useful, right? If I smell something that smells foul to me, I better not eat it. And if I smell something that's familiar and smells good, then it's probably safe. And that's the point. It's there to keep us alive, to guide adaptive behavior. So there's lots of things, if I ate them, would kill me. Smell and taste are there to keep me alive. Same thing with visual perception and auditory perception. They're not there to report the truth. They're just there to keep me alive. It's very humbling. We thought that we saw reality as it is, but we don't. And one consequence of this is that science is also built on the misconception that our senses tell us truths about objective reality. We believe, and science has assumed for centuries, that space-time is fundamental. Space and time first, but now space-time, the union of the two that Einstein put together. That space and time are the fundamental stage in which the drama of life is played out. and that the foundation of reality is physics with, elementary particles and atoms, and then protons and neutrons, and then quarks and gluons and leptons and so forth. These things are the fundamental nature of reality. And then we get the whole pyramid of science, physics at the base, and then all the special sciences above it, chemistry, biology, neuroscience, psychology, and then the social sciences and so forth. So there's this pyramid of science where the foundation is the objective reality of space-time and elementary particles, and everything else is sort of built up, emerges from that fundamental reality. And so I'm saying that that pyramid of science is also a rookie mistake. Space-time is not fundamental. It's just a data structure that we use. Particles inside space and time are just data structures that we create when we interact with whatever reality is using our space-time interface. And so the whole pyramid of science is a big mistake. And so the things I'm saying here are radical. They're going to change from top to bottom everything that we're doing in science in terms of the conceptual framework that we bring to it. What we'll keep, of course, is careful experimentation and mathematically precise theories. That's the beauty of science, that the scientific method is fantastic. It's the best tool that we have so far as a species, is careful experiments to test absolute mathematically precise theories. But the theory that space-time is fundamental and everything else emerges from space-time and its particle, or the quantum fields, is going to be seen as a rookie mistake. From the point of view of the interface, in fact, the pyramid is upside down. The standard pyramid of science is upside down. Think about what an interface is there for. And at some point, I'll tell you what I think is behind the interface. I'll just mention briefly what I think is behind the interface, and we can go into it later. I'm trying to study the problem of consciousness. What is consciousness? Our experiences of taste and smell and headaches and so forth, just these simple conscious experiences, how can we get a scientific understanding of them? And for reasons I can explain a little bit later, I'm proposing that objective reality is not a physical, unconscious space-time with particles. That objective reality is more like a vast social network of interacting conscious agents, where I have a mathematical model of what I mean by conscious agent. An agent can have conscious experiences, and it can take actions based on those experiences to affect other agents in this network. So in an infinite social network of agents passing experiences back and forth, much like Twitter passing tweets back and forth. And from that point of view, and the interface, our interface is giving us some insight into objective reality. When I interact with other people, when I talk with you, all I see is a symbol. I see a face, skin, hair, and eyes. But I have a bit of a portal into your conscious experiences. I can tell if you're interested. I can tell if you're bored. I can tell a little bit if you're happy or sad. But I know that I believe that there's an infinite realm of your conscious experiences. Very, very rich. All your hopes and dreams and aspirations, your love of music, the things that you're afraid of, all that stuff. All the colors and headaches and sounds that you're having right now. It's a very, very rich world of conscious experiences. I just get a little symbol, a face in your body that I'm creating. That's the face that I'm creating is not you. It's my symbol that I'm creating, but it's my portal into your consciousness. And so my interface gives me some good insight into some aspects of objective reality, namely some conscious experiences of what I call people. When I look at my cat, my interface is giving me less of a clear portal. And I can imagine some of the experiences of my cat. It likes this cat food. It doesn't like that. It likes it when I, have a laser light that it can chase around it. It's happy about that. It's not so happy if I'm, ignoring it. So I can get some insight into it. When I look at an ant, now the ant symbol that I've created is, the portal is getting pretty dim. I have no idea what conscious experiences I might be interacting with that's leading me to have a symbol of an ant. But the point is that the reality is always this infinite network of conscious agents. My interface is it's sort of like this. The reason we have an interface is, imagine the Twitterverse, right? There's millions of Twitter users, this vast social network, billions of tweets, tons of stuff that's trending. How can a Twitter user, a single user like me, understand all that complexity? Well, it's overwhelming. I couldn't look at all billions of tweets or even millions of users, but Twitter users. So if I wanted to see what's going on, I would need some kind of visualization tool, like to dumb it down and let me see what's trending in Irvine, what's trending in London, who's got lots of Twitter followers, who's irrelevant, and so forth. And so we use graphical user interfaces for any kind of big data, but especially social network data. That's some of the biggest data that we've got. And that's what I'm claiming our interface is. Space and time, physical objects, is just our graphical user interface to allow us to navigate this vast social network of interacting conscious agents without being overwhelmed by all the complexity of it. And from that point of view, if you think about what an interface does, an interface is there to hide most of the reality, right? The point of a user interface to big data is that the big data is too complicated. It's too overwhelming. You need an interface that's going to ignore most of it. It's going to get useful summaries. It might give you a lot of insight into certain aspects of it that you need right away. Like, I need to see who are the Twitter users close by to me here in Irvine or something like that, maybe. Whatever I might need. But then it's going to have to, do broad brush over a lot of stuff, and most of the Twitterverse is just going to have to completely ignore. I mean, because I would be overwhelmed. And that's the point of the interface, is to intelligently and selectively simplify, and then simplify and simplify and simplify, and at some point just ignore the rest of the reality. So that's what interfaces and big graphical user interfaces do. They intelligently, here I don't want to simplify too much. I'm interacting with you. I need to have the best interface I've got to your experiences so I can interact with you. With my cat, I don't need to know as much. With an ant, I'm giving up. And when I see something that I call a rock, I've just given up. There's a vast network of conscious agents out there I'm interacting with, and my interface, it has simplified to the point where I don't see anything about that. I just get something that I call a rock. I'm not saying a rock is conscious or is composed of conscious agents. The rock is my symbol. It's my graphical user interface symbol that's giving up in telling me too much about it. Just like, the blue icon for a file is not saying that, that the icon itself is composed of files or somehow is composed of circuits, it's just not. It's just my symbol. And so from this point of view, it's really interesting. What is physics and space-time? That's where my interface has given up the most. It's simplified the most. That's where our interface is giving us the least information about objective reality. As we go up the special sciences to chemistry, biology, neuroscience, and psychology, what we're actually doing is we're getting closer and closer and closer in our interface to insights about the true nature of objective reality, namely the realm of conscious agents. So the pyramid of science is turned entirely upside down. We've made a rookie mistake. It's like when I look at my interface on my computer and I say, I see the desktop, I look really closely, I see pixels. I'm saying, that's the fundamental reality. Well, no, that's just the lowest level of the interface. Space-time and particles are the least informative. That's where the interface has done the most compression and given us the least insight into reality. Chemistry, that's where we've given up a little bit less. Biology, we've given up a little bit less. Neuroscience, even less. And psychology, even less. So the pyramid of science is upside down. And so science is going to have a complete revolution. We are so fundamentally mistaken in taking physics as the fundamental realm, as the one that gives us the grounding reality, and then trying to boot up everything from that. It's just we've misunderstood. So this mistake of thinking that our perceptions are a window on the world is the big mistake in science. Really understanding that evolution has shaped us with the user interface completely turns the pyramid of science upside down. It makes us realize that things that are the simplest science, which is physics, the reason we can do physics is that that's the simplest part. The reason we get equations and make progress there is we have simplified, our interface has simplified this vast network of conscious agents so much that we can now actually finally write down equations. That's how simple it is. And that's why physics has made advances faster than the other sciences. It's not because it's fundamental, it's because that's where our interface is about to give up. It's simplified so much. The next step is just to ignore. We get things like dark matter now, dark energy. We're saying, whoa, there's a whole bit of reality that we completely ignored. We can't even see it in our interface, except maybe by gravitational influences. And who knows, there are probably, now it's in the cards that there are things we won't even see with gravitational influences. And that's exactly what we expect from an interface. So this is one of the most radical implications. If you really go down this rabbit hole and say, our perceptions were not shaped to show us the truth, it's a user interface, then you are led inexorably to the conclusion that the pyramid of science is upside down. We're fundamentally mistaken, and science is going to have a huge revolution. When it turns that pyramid the other way around, that is the biggest revolution science has ever had.
That's really interesting. That's so interesting. It's as if in the pursuit of trying to understand what the world is, we've actually sort of gone really far out into our interface and further away from the reality that you're saying is the real thing, which is the consciousness within us. But
Right.
we're sort of leaving all that behind and going out and really sort of studying the fine scale structure of the things that we're seeing out there. We're just moving really, really far away. It's almost like there's, like a projector screen or something. The projector itself is behind us and we're not really paying attention to it. We're just sort of fixated on the screen. And then we're walking over to the screen and looking at it really closely and say, look, this is where the light's coming from. This is where everything, but it's way back there. That's a really interesting point.
Yeah, so from this point of view, this is the biggest mistake science has made so far, which is to assume that our senses were shaped to show us some aspects of the truth, that space and time as we perceive them is a genuine insight, and that the language of space and time, the language of matter, shapes in space and time, is the right language to describe objective reality. I mean, they've gotten far more sophisticated than our casual representation, of course, but it's still inside space and time. It's still mass and things like that. And they've assumed that that's the fundamental reality. No, that's just where our interface gets so simple that it's data compressed so much that we can, now it's simple enough that we can actually write mathematical equations and see what's going on there. So we've just missed, it's a rookie mistake. And so this is the big one. We have to really come to grips. Are we seeing the truth in part? Or is this really fundamentally just a user interface? And if it's just a user interface, the whole game of science is different. All of our scientific theories so far have been theories within the interface. We've been exploring our interface and we've been doing a good job. We've had no idea that there is a whole realm of reality outside of space and time. It's not inside. Space-time itself, it has a grip on our, we can't imagine what could be beyond space-time. It's hard for us to imagine. And I'm saying we have to do that to make the next step in science. We have to imagine a reality that simply is not contained in space and time. It's utterly outside space and time. Space and time is just our user interface. It's our conceptual system. The reason it's hard for us to think outside of it is because that is our conceptual system. That's what we were shaped with. It's our interface. But we do seem, with some effort, able to think outside that box. And so that's what I'm saying we'll have to do. We'll have to now get a science of this vast social network of interacting conscious agents, a mathematically precise science of it. And then a science of our interface. How is space and time, physical object and so forth? What exactly is the mapping from this network of conscious agents that projects into our user interface? So we have to work that out with mathematical precision. Then we'll know, the way we'll know if we've got it right right? So I want to do science here. I want to have falsifiable predictions. The way we'll know that we can, well, testable predictions. You can't really falsify. You can't prove anything in science. You can't prove your theories are true, but you also can't prove in general that they're false. You can just get levels of confirmation or disconfirmation. That's the more correct way to talk about it. So how will I get evidence that could confirm or disconfirm my theory? And the idea is this. We'll create mathematical models of this realm of conscious agents, a mathematical model of how the interface is projecting that dynamics of conscious agents into space and time. And then, when we project the dynamics of conscious agents into our interface, we have to get back general relativity, quantum field theory, the standard model, evolution by natural selection as the interface projections of the deeper dynamics of conscious agents. If we don't get that, our theory of the conscious agents is wrong. We need to revise our theory of conscious agents until when we project it into our interface, we get back the sciences that we work so hard. So the current sciences, the scientific theories that we have are fantastic. I have the deepest respect for general relativity, quantum field theory, evolution by natural selection. They're incredible triumphs of human science. They're theories of the interface. And so they will serve as test cases for our deeper theory of the dynamics of this vast social network of conscious agents. That network dynamics must project to these theories, hopefully project to the theories like evolution, quantum field theory, and general relativity, hopefully project and expand them a little bit, maybe get finally a theory of quantum gravity that comes out of it. In other words, that we'll keep everything that we understand from the theory so far and maybe get even deeper insights. That is the kind of test that we can use. So people can say, well, how can you possibly test a theory of conscious agents that's not inside space and time? That's how you do it. We can do real science on this. But from that point of view, we have never yet had a science of anything outside the interface, because we didn't know that space and time was just an interface. There are the first hints of this in physics. If you Google the phrase space-time is doomed, space-time is doomed, you'll find that there are a number of first-rate scientists, physicists, who are saying this. Ed Witten has said it, David Gross, who won the Nobel Prize for his work on the Standard Model, and Nima Arkani-Hamed, who's professor of physics at the Institute for Advanced Study at Princeton. And he's saying this: space-time has had a good run. Space-time in physics for centuries has been about what happens in space and time. That's what physics has been. It's what happens in space and time. And now they're realizing that they're going to have to let go of space-time. It's not fundamental. There's something deeper, more fundamental, and space-time is going to be an emergent concept from that deeper thing. And some of the reasons I should go into just briefly about why they're saying this. But the big point will be, I'm saying that space-time is doomed because of evolution by natural selection and the theorems that Chetan and I have worked on that say that space-time is just a user interface. If space-time is just a user interface, it's not the truth, then it's doomed in terms of being fundamental reality. It cannot be the foundation of a science of objective reality. So space-time is doomed from the point of view of evolution by natural selection. The physicists are now saying the same thing, but they say it for different but converging reasons. The first, well, one has to do with the Heisenberg uncertainty principle. And the point is that you can't measure position and momentum with precision at the same time. And the more precisely you measure position, the more energy you need to use. And part of the problem with space-time is that at some point, as you try to measure, if space-time is real, we should be able to measure it, at least in principle. And it turns out, in principle, as you measure smaller and smaller areas of regions of space-time, the energy that you're going to require to do that, it gets bigger and bigger. And eventually you'll have to have so much energy concentrated in such a small region of space that you create a black hole, which means that the very act of measurement is no longer possible. And if you say, well, I'll try to look closer, I'll use more energy, you just make the black hole bigger. So the very notion of space-time gets destroyed beyond a certain small size, because you destroy it. And that's already a hint, and physicists like Nima Arkani-Hamed will point this out. They'll say, look, the fact that it in principle cannot be measured is telling us that there's something wrong here. This is not a fundamental concept. There's got to be something deeper. And then there's empirical data as well that's suggesting this, from the Large Hadron Collider in Geneva, where they send pair of protons in opposite directions around these loops at nearly the speed of light, and they smack into each other. And then the inner guts of the protons will sometimes, the quarks and gluons will smack into each other. And most of the time, what comes out is stuff that is physics we know, and we're looking for that rare event where we get something new smashes and gets out and we see it. And what they have to do at the Large Hadron Collider is compute what they call scattering amplitudes. What is the probability that 2 gluons smack into each other and 4 gluons go spraying out, or 5 gluons go spraying out, or 6? And for each one of those, if you can do the computation, and you have to do the computation so that you can ignore them, right? You can. And by the way, you're doing a billion of the, billions, or I don't know how many. There's lots of these collisions per second. It's billions, or maybe even trillions. I don't know. I think billions. And so you have to ignore most of them. So it turns out, if you do the computation the way Richard Feynman told us how to do them in space and time, looking at all the virtual particles that will come up, these things smash together. Now there are all these virtual particles and then eventually 4 gluons, asymptotically go out. When you do all the math, and you can compute the scattering amplitudes, but it ends up in most cases being hundreds of pages of algebra. It's an absolute mess. And even supercomputers couldn't keep up with it. I mean, at these rates. So about 30 years ago, the experimentalists basically said to the theorists, please help us, right? We really can't do these collider, Large Hadron Collider kind of experiments, other collider experiments, without you simplifying this math. We can't do hundreds of pages of algebra billions of times a second. It's not going to work. And so some mathematicians got to work on it, and they were able to get 100 pages in one case down to 10, which was like, whoa, those guys are really hot. And then a year later, they got it down, or a few months later, they got it down to one or two terms that you could compute by hand. And it was like, whoa, that's a miracle. How did you go from 100 pages of algebra down to one term that you can compute by hand? And they thought, well, that's just a one-off. Maybe, that worked for one collision, but it won't. Well, it turned out over the next decades, they discovered time and again that each new collision, you could get it down to 1 or 2 terms. And so when they finally said, well, what's going on here, right? What's going on is and Nima Arkani-Hamed and his collaborators are the guys doing this. They've discovered that there's some structure they call an amplituhedron. Amplituhedron. It's a geometric structure that's not in space-time. It's outside of space-time. It has symmetries that cannot be expressed in space-time. It's deeper than space-time. And when you do the computations of the volumes of this structure outside of space-time, that gives you these scattering amplitudes. That gives you these probabilities. And it gives you, it gets rid of all the nasty math, and it gives you very simple expressions. So here's the thing. When we assume space-time is fundamental, we get nasty math that we can't compute. It's ugly. And we cannot see some very deep symmetries in nature. If we let go of space-time, we can go to a deeper level, which they don't know what that level is about. All they're doing is they're getting this mathematical structure. They have no idea what it's about. You start to see symmetries that aren't expressible in space-time, and the math becomes simpler. So space-time is doomed. They don't know yet what's going to replace it. The amplitude-hedron is a pointer. It's saying there's some really beautiful stuff once you let go of space-time. And I'm saying from the point of view of evolution of natural selection, yes, all of reality is outside of space-time. Space-time is just our user interface. Space-time is doomed. We've had a good run. We've done science within space-time. It's been very, very important. We have not wasted our time, because the deeper theory of science, of this vast interacting network of conscious agents, will have to give back all of our science of the interface when we project the deeper science into our interface. So all of our work we've been doing is not wasted. It's very, very valuable. It's the necessary guide for jumping into reality in science and getting a model of reality for the first time. So space-time is doomed from the point of view of physics and from the point of view of evolution by natural selection. Our best sciences are saying the same thing, and it's time for us to take it seriously.
God,
that's a long.
Yeah, no, that's absolutely mind-blowing. I don't know where to start. So, okay, I just want to kind of summarize for my own for my own sake. Okay, so we have this model of reality. We experience it as space and time and matter. And you're saying, no, that's just an interface. It's all just symbolic. And then
any compression.
Yeah, and so that's the interface theory. And then you go on to this. Well, what all of that is symbolizing is a much deeper reality. That's actually the true reality.
Right.
And that true reality is not a world of space and time and physical objects and matter. It is, well, it just is consciousness.
Right.
And specifically, you call it realm of conscious agents. So the consciousness that's there is a sort of self-interacting network. And so why do you make the assumption that it's consciousness that is a true reality? Why not something like information, which is what other people have proposed? What is it about consciousness specifically that made you think, okay, let's go with this as the fundamental nature?
It's a great question, because and again, in science, you can never know that you're right. All you can do is try to be precise so that you can figure out precisely where you might be wrong. And so the reason I'm proposing and exploring the idea that reality is a vast network of interacting conscious agents is, I can argue for it in a couple ways. One is, it's quite possible that I have no true beliefs, that I know nothing. Quite possible. I can't dismiss that possibility. But if I know anything, truly, it's that I have conscious experiences. I have a headache. I do smell the smell of vanilla and so forth. Those kinds of conscious experiences. If I'm wrong that I have conscious experiences, then I think there's no possibility of any kind of human knowledge and no possibility of science. So for sake of argument, I'm going to assume that I'm right, that there are conscious experiences, that I do have experiences that I describe as an apple and the sun and the moon. But they're real as experiences. They're not real as objective realities that would exist even if no one experienced them. They're real just as experiences. My headache, right? You can't experience it. No one else can experience my headache. And if I weren't here, that headache wouldn't exist. So it's not objectively real in the sense that it would exist even if there were no creature to perceive it. It's not objectively real in that sense. But it is objectively real in a different sense. It's a real experience. So I want to propose, and this is a scientific hypothesis that could be misguided, that conscious experiences exist. And because as a scientist, I want to have as simple a foundation for my theory as possible, I'm going to only assume that what exists are conscious experiences. I don't want to also assume that there's an unconscious realm of space, time, and matter that fundamentally exists. That would be a dualism. What we want as scientists is a monistic theory, and as simple a monistic theory as possible. The more assumptions you make, the more miracles you're building into the start of your theory, and the less you're explaining. So you want to have as few assumptions as possible at the foundation. You can't escape some assumptions. Every theory has to have some assumptions. You can't explain everything, but you want to have as few assumptions as possible. So I'm going to assume that conscious experiences exist, and that, so I've written that idea down, that conscious experiences exist in a formalism, because as scientists we want to be precise, so we can figure out precisely where we might be wrong. So I write down what I call a conscious agent. It's an entity that has conscious experiences. It has a collection of conscious experiences that it could possibly have, and then it has the ability to choose how to affect the conscious experiences of other agents. So it's one, I think Twitterverse is a really good metaphor for it. Other tweets affect my experiences, and my tweets affect their experiences. It's about passing experiences around. But the difference here, Twitterverse is a good metaphor, but the difference, a couple big differences. This is an infinite social network. And there are very, very simple, one thing that the mathematics has shown me is that when conscious agents interact, they create a new conscious agent. So they're going to be very conscious agents from the very, very simple to the intermediate to the infinitely complex. Literally, we can talk in this mathematics about infinite conscious agents. So we will actually, here's a case where science and spirituality will in fact touch, that we will have mathematically precise descriptions of infinite consciousnesses that we can test, that we can make predictions about. So we can, for the first time, have a mathematically rigorous scientific spirituality. So I'm very interested in going there. But so the idea will be that there's, so the reason I'm going after this then, the first reason was, if conscious experiences don't exist, then I'm willing to cry uncle about doing any science. The other reason I'm going after it is one of the big unsolved problems in modern science is the so-called hard problem of consciousness. And if you Google that, you'll see a lot about the hard problem of consciousness. But the idea is this: we have, in the last few decades, collected hundreds of very interesting bits of experimental data about correlations between conscious experiences and brain activity. For example, if I take a very strong magnet called a transcranial magnetic stimulator, TMS unit, and touch it roughly there to near area V4 of visual cortex of my right hemisphere, and I put the magnet in inhibit mode, then as I watch, I'll see all color drain away from the left part of my visual world. I'll see just shades of gray. I'll still see objects and motions and so forth. They've just been stripped of their color. So my conscious experience has been changed by my intervention with this magnet. I turn the magnet off, and the color experience comes flowing back in. If I do it on the left hemisphere, then I'll lose color on the right visual field. So I can intervene. I intervene with the magnet. I can turn on and off my color experience. If I excite cortex there instead of inhibit, then I'll get what are called color phosphines. It's almost like having an LSD trip with colors that you're making up there. And there are hundreds of correlations. I use that one because it's very vivid, but we have hundreds of correlations. And here's the scientific question. That's the hard problem of consciousness. Find a theory that explains these correlations. Give a scientific theory that explains why there are these correlations between brain activity and conscious experiences. And it turns out we can't do it. There is not a single theory to date that can explain even one conscious experience. So, like the taste of vanilla. Most of my colleagues are assuming that neurons exist when they're not perceived. because they assume that we're seeing reality as it is. Space and time and objects are reality. So they assume neurons exist and have genuine causal powers. And they're trying then to show how systems of neurons and their dynamics could somehow, or properties of neurons, like their microtubule states and so forth, could somehow create or generate or give rise to conscious experiences. So great. Hats off. They should try to do that. But they have failed to even explain one experience, like the taste of vanilla. What is the neural network dynamics that has the right kind of like integrated information, causal structure, or the right microtubule orchestrated collapse? These are kinds of theories that are out there. Give me one example of an orchestrated collapse of microtubules or an integrated information system with the right causal structure that is or causes or gives rise to the taste of vanilla, or any one conscious experience you want. It could be the smell of garlic, a particular color of red, whatever it is. Just give me one, so we can have some real science here. They can't give one. And the theory would need to explain why this dynamical structure, why this dynamics of neurons must be the taste of vanilla. It could not be the taste of garlic, and it could not be the sound of a trumpet. We want a principled scientific theory that says exactly why there is this correlation. And as you can see why that's pretty hard. How could it be that sodium and potassium and calcium ions flowing through holes in neural membranes is the smell of vanilla or the taste of garlic? How can you? It seems like there's a huge chasm there, going from neural activity or from quantum states of microtubules and their orchestrated collapse to the taste of vanilla. And I've asked in public, the authors of these theories to give me one example. Give a nice abstract idea, but we're trying to do science here. Give me one specific account for one specific experience, please. They can't do it, despite decades of effort. And I think it's principled. You cannot boot up consciousness starting with unconscious ingredients. If you start with space-time and physical objects which are unconscious, it is impossible to boot up consciousness without having a miracle, a rabbit being pulled out of the hat at just the moment that consciousness appears. So my approach then is just reverse things. Instead of starting with space-time and unconscious particles and trying to boot up consciousness, let's start with consciousness, mathematically precise theory of consciousness, which I have, theory of conscious agents, and we'll evolve it. I'm probably wrong, so we'll continue to evolve the mathematics. But we'll start with a theory of consciousness and show that space-time and physical objects just emerge as a user interface, a graphical user interface or multi-sensory user interface that certain agents within this vast social network use to simplify their interactions with this network. And I can imagine then that there are an infinite variety of different interfaces. Our space-time interface is just one of an infinite variety of different interfaces that can be used out there. And so those are the two motivations I've had. First, if conscious experiences if we're wrong about having conscious experiences, then I think it's, time to cry uncle about any science. And second, with the hard problem of consciousness, we have failed to start with unconscious ingredients and boot up consciousness. I think that's for principled reasons. But it turns out it's pretty straightforward if you start with consciousness to boot up space, time, and matter just as a user interface that's data compressing, simplifying this vast network of conscious agents. The mystery gets resolved. It's not a mystery, it's just a nice technical problem. So that's why I'm taking consciousness as fundamental.
Right. And so everything that we experience then in that interface is symbolic, as you mentioned. So all phenomena that we experience is symbolic, and that includes the brain, that includes nervous system. So when we look at the brain of a human being and we say, oh, it's the generator of conscious experience, in your theory, we're actually wrong. We're not looking actually at what is the conscious experience, or we're not really looking at where the conscious experience is coming from. We're just seeing a symbol of something that you're saying is consciousness. And there's an analogy that I thought of. It's almost like the brain is a lens through which we interpret the interface, I guess, or interpret the universe in the same way that, like, let's say you were in a dream and we're conscious in a dream, we're aware of things that are going on, but there's no real external world there. Is that it's just the world, the dream world in our minds. And so if you had a lens that you held up to your face in the dream, it's made of dream stuff. It's just in the dream still. And you had this lens and you're looking at the dream world and it sort of distorted the way it looked, and maybe it tinted it red and the glass was a bit bent in the lens. So the world looked a bit wobbly and strange. And so you'd say, okay, this is the way that the world really, really is. And the lens here is the producer of my experience. But of course, you're completely missing the fact that you're not the lens. You're the consciousness that's experiencing the world through the lens. And so in the same way, in our reality, we are not our brains. We're not our nervous systems. We are the conscious agents that are experiencing our interface through whatever the brain and nervous system is. But in our interface, we see a brain and nervous system, but it is some sort of thing that our consciousness is experiencing this interface through.
Exactly. I agree. So to be very stark about it, right now I don't have a brain.
Okay.
Some of my colleagues would agree. and neurons do not exist when they're not perceived. Neurons are symbols that we create when we look inside skulls with microscopes, and otherwise they don't exist. There's something that exists. And that thing that exists is not even in space and time. So I'm not saying that some people say, well, maybe consciousness is fundamental and the brain is a receiver for consciousness. Well, that would assume that the brain really exists. And I'm saying the brain is no receiver for consciousness because it's just a symbol created within consciousness. It's not something that has any real causal power. Now, in everyday neuroscience, and I've collaborated on fMRI and EEG experiments. I'm all for neuroscience. And so nothing that I'm saying is trying to impugn neuroscience research at all. I'm all for doing neuroscience. And I think it's wonderful stuff. And in everyday neuroscience, I'll talk about neurons as though they exist and as though they have causal powers. It's a useful shortcut. It's a useful shorthand. I mean, I'll say that area V1 of visual cortex, the neurons there have activity which projects to area V2 and causes certain changes in the activity of area V2 neurons. They have a back projection to V1, which, and so forth. And for everyday neuroscience, that's perfectly fine. It's harmless. It's a harmless fiction. In fact, it's a useful fiction to talk about neurons and neural systems as though they have causal powers. For everyday neuroscience, there's no problem with that. I'm perfectly fine with it. With a wink. I mean, we know that it's that literally speaking is not true, but it's a useful shorthand. It's only when we try to look at the hard problem of consciousness, how is neural activity related to conscious experiences, that the fiction is no longer harmless, that it comes back to bite us. It's much like someone playing, suppose we're all experts at Grand Theft Auto and we're learning all sorts of new tricks and hacks about what you can do. Oh, do you know you could do this over here and then you'll get this new tool and so forth. And so we become masters of Grand Theft Auto and we believe that the steering wheel really does cause cars to move, that the objects in the Grand Theft Auto world really have causal power. And for playing the game, that's a harmless fiction. It's perfectly fine to think that the steering wheel causes your car to move. It's perfectly fine to think that if I throw a rock, it causes the windshield to shatter. And it's perfectly fine. For everyday Grand Theft Auto, if you're just a user, that's perfectly fine. However, if you're a software developer and you're trying to get the next generation of the software, if you believed that the steering wheel was real, good luck trying to do that. You've made an assumption that's so stupid, so rookie, that you'll never be able to actually write the software. You need to understand that there's a deeper reality behind the software world of Grand Theft Auto. And all that circuits and software, you're going to have to be very sophisticated about that to make this useful fiction of cause and effect within Grand Theft Auto. And that's the same thing with neuroscience. For everyday neuroscience, we're just inside the interface. And we do need to do that research. So more power. I hope there's more funding for it. We're just working on our interface description. And there, the fiction of neural causality is perfectly fine as a useful shorthand. But when we go into the big leagues, we're trying to really now not just be playing in the interface, we're trying to see how the interface relates to objective reality. Now we have to up our game. The idea that neurons have causal powers is the same rookie mistake as thinking that my steering wheel in Grand Theft Auto really does cause things. That's a rookie mistake that you just have to walk away from, or you don't have a prayer of getting to the deeper theory. So I'm all for neuroscience, and I've given lectures to my colleagues in the neurosciences, in which I'm all for neuroscience, and for everyday neuroscience, it's fine to say that neurons exist and have causal powers. But strictly speaking, brains do not exist when they're not perceived. Neurons do not exist, and neurons have no causal powers. My brain causes none. Well, I don't have a brain, so it doesn't cause my experiences. It causes none of my actions. My brain causes nothing, strictly speaking. For everyday neuroscience, I will talk as though it does. But when I really want to understand how perception is related to an objective reality, I've got to walk away from it. It's pretty surprising, but from the interface point of view, it follows directly that we create physical objects on the fly. They're just data structures. So the brain is a data structure that we create on the fly when we look inside heads. But now, from the point of view of this interface theory and conscious realism, the question is, what can we infer from our interface about the nature of the conscious agents, right? So, and we have to be very, very careful. So, when I look at your face, I'm not directly seeing your consciousness. I'm just seeing skin, hair, and eyes. So the interface, in some sense, is hiding the rich world of your conscious experiences, but it's just giving me little insights, right? Like if you smile, I can guess that you're feeling the conscious experience of happiness or joy or something like that. But a smile does not resemble happiness, the conscious experience. They're utterly different things. And then there's no resemblance relationship at all. So there's going to be this mapping that we have to work out between what do we see on our interface and what does it mean about the conscious experiences. So a smile is just some contortion of lips and skin and hair and eyes. But that symbol in my interface is a pointer to a conscious experience, namely happiness. And frowns and so forth would be a different contortion of muscles on the face, and that would be a pointer to a different conscious experience. So you can see that we're going to have to come up with a translational language between what we see on the interface and what's going on in the realm of conscious agents. That's going to be part of understanding what our interface is and how it's projected, this network of conscious agents, into our interface. So when we look inside brains, and we see these interesting, it's really fascinating, right? That all these, there's 86 billion neurons in the cortex. And there are all these amazing pathways. And we're now studying the connectome, the default mode network, and the visual attention network, and the auditory attention network, and so forth. These interacting networks, and then systems of neural, projections and back projections and so forth. The question will be, what legitimate inferences can we make from the structures that we see in the brain activity back to connectivities and patterns of interactions in the vast social network of conscious agents? And we'll have to, we will have to get that dictionary. What is it? What can we infer from the network of conscious agents to the network of, from the network of neural networks, and their connectivity and actions to the network of conscious agents? We'll have to be very, very careful. Presumably most of our initial guesses will just be wrong. We'll just have to try to figure out what is that mapping. And whatever the mapping is, when we go down from, neural networks down to biochemistry, again, we're going to have to understand how does the biochemistry get pulled back to the network of conscious agents. And then when we get down to physical chemistry, how does that get pulled back? And then finally physics and so forth, how does that get pulled back? So once we do that, we'll really then thoroughly understand our user interface and how it's related to the network of conscious agents. And once we've understood our interface, watch out, because then we will have unbelievable new technologies available to us. Once we understand our interface, we can hack it. In principle, we should be able to hack it. And so I'll give just one example with artificial intelligence. One big question right now, it's becoming clear that artificial intelligence, at least artificial narrow intelligences, will beat us at any specific task that we give them. It's very, they'll beat us, they're beating us at Go, they're beating us at chess, they'll beat us at object recognition, any specific task, they'll beat us at it. They'll be beating us at research. People like me will be out of a job because we just won't need second-rate minds like mine to do original research when AIs can do better. So there's that, but the big question now is, could AIs be conscious? Not just in some sense beat us like tin cans that are beating us at our own games, but really go beyond tin cans to really having emotions and experiences. And the standard way of thinking about this is a physicalist framework. Again, everybody assumes that space-time is fundamental and physical objects exist and are real, even if they're not perceived, and it's all unconscious. But maybe if we get the right complexity of silicon circuits and voltages and magnetic, we get the right level of complexity, somehow the magic of consciousness will ignite. And we'll have actual consciousness emerging. and we've had lots of discussion in that vein, and no one has a way to figure out how consciousness could emerge from the silicon or whatever it might be, the hardware. I reframe that question entirely. That whole way of framing it, I claim, is wrong from the start. There's nothing to be saved from that framing. Rather, the question of artificial intelligence and consciousness is this. Reality is a vast interacting network of conscious agents. That's what it is. Space and time, silicon, and voltages are just our interface descriptions, our interface symbols, as we interact with this pre-existing realm of conscious agents. We know, or at least we believe, that our interface is giving us portals into the realm of conscious agents. When I see what I call your face, I'm getting a portal into your conscious experiences. Fallible, but genuine portal. Here's the question of AI. Is it possible to understand our interface so well that we can rejig our interface using silicon and software and so forth to open a new portal into the realm of conscious agents? We're not creating new consciousness. We're opening a portal into this pre-existing realm of conscious agents. That's the new way of framing the AI consciousness question. For what it's worth, I think the answer is yes, in principle. Once we understand our interface, once we've really reverse engineered our interface, and that's going to be some work. We'll have to have a theory of network of conscious agents that's really precise, really worked out, a theory of how that maps into our Homo sapiens specific space-time user interface in great detail. Then we will have the tools where we can then start to hack our interface. I have portals into your consciousness. I have portals into my cat, portals into my into an ant. Can I rejig my interface and open new portals into this pre-existing realm of conscious agents? I think so, but that's a brand new way of thinking about it.
Yeah, the conscious agents that you're talking about there might be the ones that you talked about earlier briefly when you said that if two conscious agents interact, then they form a new definition of a single conscious agent, which neither of the original constituents is actually aware of. They're only aware of each other, but as they interact, they form this new conscious agent. And so this is something I wanted to get onto really was, let's say like lots and lots of people are interacting and it all feels like they're all separate individuals. To each person, it feels like they're just a single person in a crowd of people. But what you're saying is all those conscious agents, all those people, conscious people interacting, are forming what you call an instantiation.
Right.
And that's a single conscious agent in itself. So 500 people are interacting. They feel separate, like individuals, but they're actually a conscious agent in union. Why can't they experience what that conscious agent is, and what might that conscious agent be? And so, like, we can't experience it in our interface. And so what is it? If it isn't some tangible thing that we can point at and say, there's the conscious agent over there. Right. Where is it? Well, I guess it's not in space and time, right? So it's not anywhere.
Great question. One very interesting feature of consciousness is what's called privacy. So I directly experience my headache. And if you tell me you have a headache, I can empathize. I can feel for you because I've had my own headaches. But I can't experience your headache. Your realm of conscious experiences seems to be sealed off from me. You have access to your experiences in a very special way. I have access to my experiences in a very special way, and no one else has access to them. And that's a stunning and apparently fundamental property of consciousness. And so I'm modeling that in my definition of conscious agents. And when we actually have two separate conscious agents, the separateness of the mathematical structures is our mathematical analog of the privacy of the conscious experiences of this agent and that agent. So the separate mathematical structures are actually separate as a model of conscious privacy. Why this conscious agent's experiences are open to it, but closed to this other agent, and vice versa. Now, when there's going to be, I'm fascinated to see how the mathematics works out, but when two agents interact, a new agent is formed, and it has its own, because it's a separate structure, it has its own privacy. Now, I think the way the math is going to work out, and we're going to have to work on this, is that the two agents that interact to create this new agent will be kept private from, they will not be able to see or experience the experiences of the agent that they've created. But the agent that's above them may have some of the experiences of its instantiating agents, the agents that combine to form it. It may have access to some of their conscious experiences. So the quote-unquote privacy may be breached downwards, but not upwards. So I'm going to be looking to see if the mathematics actually says that. But again, even going downwards, it won't be a complete breach. The higher level agent will not necessarily have access to all the conscious experiences of the agents. And that's why when we talk about, our own mental processes, well, when I teach a big class called Introduction to Psychology Fundamentals. I'll have 450 undergraduate students, lower division students. And one of the things I'll tell them at some point during the quarter is that, 99% of your mental processes are unconscious. And that's the standard way it's put. And the way it's mostly interpreted is, well, yeah, because brains are fundamentally physical systems that aren't conscious, and most of their processing isn't conscious. It's only a little bit of that processing that becomes conscious. But I'm thinking about it in a very different way. Most of my mental processes are unconscious to me. That doesn't mean that they're unconscious. Your conscious experiences are not conscious to me. But I would be stupid to say, because your experiences are not conscious to me, therefore you must be unconscious. That would be really stupid. That would be very, very egocentric. Just because I'm not aware of your conscious experiences, it doesn't entitle me to say you're necessarily unconscious. The same thing with my own mental processes. Just because I'm not consciously aware of them doesn't mean that they themselves are unconscious. I'm claiming that it's conscious agents all the way down. And a higher level conscious agent that's formed by all these interacting conscious agents will be able to have some understanding of the conscious experiences below it, but not total. It will only be able to go down so far. So, and it probably is getting like probes. I'm getting these experiences over here, now I'm getting these experiences over here, these experiences, and that's what we call our changing attention. As we change attention, we're literally, in some sense, accessing other private experiences within our instantiation. But we can only go down so far. At some point, I don't get any experiences related to what I would call the chlorine atoms in my body. I mean, it's not going to happen no matter how much I introspect. I'm not going to be able to go down that far. And so one of the things that this theory of consciousness is going to have to deal with is the point your brain, which is we'll really want to understand these privacy relationships. Why, when two agents interact, does the mathematics really say you can't breach the privacy above you? That would be very interesting. You might ask, well, what kind of empirical data could we possibly have to try to constrain a scientific theory? And we have some interesting data that we have to be careful about, because all of our data is through our interface. So any data that we have is going to be an interface description that we have to really be careful about how we're thinking about the interface and this relationship to consciousness. But here's the interface data we have. Split brain patients. These are people who, unfortunately, have had trouble with epilepsy that can't be cured with existing drugs. And in some cases, their seizures become so frequent and so severe that they're destroying the quality of life, and they're actually, in some cases, life-threatening. In severe cases, they've gone to a very dramatic surgery. The brain has two hemispheres, left and the right hemisphere. Each has about 43 billion neurons in the cortex. And the two hemispheres have a connection between them called the corpus callosum. It's a band of about 200 to 225 million axons, fibers. And the idea of the surgery was this: suppose that the right hemisphere is the hemisphere that's got the problem, that's causing the seizure. Well, if I cut the corpus callosum, maybe only the right hemisphere will go down with the seizure, and maybe the left hemisphere can stay awake. That was the hope. And it worked. I actually had the pleasure of knowing Joe Bogan, one of the surgeons who did the surgery. So you very, very carefully shave the head, take a skill saw, cut off a bit of the skull bone, then take a scalpel, go in there and cut the corpus callosum very, very carefully, and then put the skull bone back in. And it worked. Well, now it's very interesting when you actually then talk with the people afterwards. Now the two hemispheres have been, in some cases, almost completely disconnected from the corpus callosum. There are some brain, hindbrain connections, midbrain connections, but all the cortical connections can be severed. What you find is the right hemisphere can have conscious experiences utterly different from the left hemispheres. And the left hemisphere at the same time is having a different experience than the right hemisphere. And they don't know what the other one is experiencing. They can't say.
So there's two centers of conscious experience in the same skull.
In the same skull. It seems like we've used that Joe Bogan used his scalpel to cut consciousness in half. And it's hard to imagine that consciousness is something that you can cut in half with a knife. I mean, you would never think you could cut, the very idea, could you cut consciousness in half with a knife? Stop talking nonsense. That seems so silly that you could even think. But Joe Bogan did it. And the right hemisphere in one patient, this is V.S. Ramachandran, a friend of mine studied this one patient. The right hemisphere was an atheist. The left hemisphere believed in God. The right hemisphere wants to be a race car driver. The left hemisphere wants to do something very, very safe, like be a draftsman. They have different personalities, different conscious experiences, different religious orientations. It's truly stunning. And so the idea that seems to be revealed from the split brain patients is that each of us thinks of ourselves as one unified person. I am one consciousness. But a swift switch of the knife through the corpus callosum, and all of a sudden you're two consciousnesses. And when you ask here's the interesting thing, Michael Gazzaniga, has asked the left hemisphere and the right hemisphere, does it feel any different now than before when you were connected? And the answer is no. And that's stunning. That we need to follow up on that and do more careful experiments. But if that result holds up, it would be empirical data that the two. So the idea here is that there's a left hemisphere conscious agent, roughly, my symbol of a left hemisphere is pointing to a conscious agent. I'll call it the left hemisphere conscious agent.
Yeah.
The left hemisphere itself isn't conscious. The right hemisphere is a symbol pointing to a conscious agent. I'll call it the right hemisphere conscious agent. Somehow, when the corpus callosum was intact, there was another conscious agent, the me at the top. When I cut me in half, and I now look at these two conscious agents, each one will say, nothing to see here. It's the same as it was before, which suggests, again, the empirical data that they were unaware of the higher level agent that they were creating. But the higher level agent is aware of the dissonance, perhaps. I mean, sometimes I don't know what I want to do. It's Friday night. Do I want to study? Do I want to party? Part of me says study. Part of me says party. Well, that could be a real debate between two separate conscious agents. The right hemisphere might be saying party. The left hemisphere might be saying study. And I think it's just me that's having this internal dialogue. It could be that me that's having there's really two separate conscious agents that are really at odds and not happy with what the other one wants. And I'm adjudicating that. That would be just the tip of an iceberg. The left hemisphere agent has an infinite lattice of conscious agents underneath it, and it goes all the way down. So this is the kind of data we're going to be really, really careful. Once we realize that our interface is just an interface, science becomes more complicated. Before it's been simple. You see space, there is space. You see objects, there are objects. Now it's no. I see something, that's just my interface description. I have to have an entire theory about how my interface is related to objective reality. Science becomes far, far more sophisticated now. And the fact that we haven't even noticed that this is an interface is like, duh. I mean, it's like, we haven't even got started. We haven't really started yet. And our understanding of consciousness, we haven't even started yet. So we're at the baby beginnings. We have all the work is ahead. Everything that we see now, we have to question. This is an interface. What could it possibly be representing in this deeper reality? What is this deeper reality? So there's great job security in all this. We're just science in some sense. I mean, science has only been around, based on how you talk about it, since, say, Galileo and Newton. You could push it back to the Greeks, but it's been just a few centuries, maybe if you're generous, a couple millennia. Our species has been evolving for hundreds of thousands. It's been around for at least a couple 100,000 years, and our hominid ancestors, millions. So here we are. It's only been in the last couple thousand, maybe really the last 400, that we've really got started on science. So science is just booting up. It's a newfangled tool that we've got. And so far, we've only been using it to study our interface. We had no idea that we were just studying our interface, but that's all we've been doing. Now it's time for science to get real, to actually get models of reality and to really understand our interface and how our space-time interface it gets hooked up to the subjective reality. So all the work is ahead. Everything up till now has been the easy stuff, and it's not seemed easy. The hard work is ahead. It's going to be fun.
Okay. So I wanted to ask you a little bit more about, you were mentioning the AI, and then we talked about how these conscious agents, as they interact, form a new conscious agent, and we are what it feels like to be the union of our left and right hemispheres, which are actually separate conscious agents in their own right. And so as people and things are interacting, and whole societies of people all over the world, all those complex interactions are forming higher conscious agents that no one in our three-dimensional conventional reality is aware of. But
Right.
in your theory, that they are there. And so,
Right.
you know, these vast sweeping social changes and things like this could be seen as possibly the actions of higher conscious agents in some kind of higher state of perception that we are not aware of. And if that's
Yes.
the case, you were saying, well, maybe AI and future technologies will allow us to open up portals of perception to these conscious agents that could be higher or lower than us, our
Yes.
instantiation. But also that, I mean, that might be very good, and we might be able to understand a whole lot of reality from doing that. But also makes me think, well, what about the very building blocks of the theory, where you say that the mathematics showed that if we do experience reality as it truly is, then things tend to go extinct. Could it be possible that by yeah, you kind of see where I'm getting at? Like,
Right.
the more we open ourselves up to the truer nature of reality, whatever it is, maybe that won't be so good for us. I don't know. I don't know what your thoughts on that were. It's just something that
Great question. And that brings out a whole other aspect of this thing that I haven't talked about. And that is, I used evolution by natural selection and evolutionary game theory to make the claim that this is just an interface, it's not the truth. But then I'm saying the next step is space-time itself is not fundamental. There's a deeper reality of conscious agents. That deeper reality has a dynamics that when I project it back into space-time, we'll get evolution by natural selection. So in a deep sense, evolution by natural selection is not the ultimate theory. It's not deeply true. It's only true vis-a-vis our interface. So I've used the theory of evolution by natural selection as a ladder to get up to a new level of conception, to transcend space and time. But now, that doesn't mean that the ladder was true. It doesn't mean that the ladder is precisely, definitively true. We may have to realize that the very tool that I used to reject space and time as being fundamental is itself only a projection of a deeper theory. It may be, if you look at evolution by natural selection, this is a point that I'm going to be exploring. Evolution by natural selection only happens if there are limited resources. If the only reason I need to compete with you is because there's not enough. There's not enough food, there's not enough mates, whatever it might be. The only reason that there is competition and selection, you know, that some fail and some succeed, is that in some sense it's a zero-sum game. You know, if there are winners, there have to be losers. And it's the assumption of limited resources that's the dynamic that drives the dynamic of evolution by natural selection. That assumption may be an artifact of our interface. Interfaces take an infinite reality and smash them down into something finite. They place limits. It could be, and this is something I'm really interested in, that evolution by natural selection and its assumption of limited resources is deeply false. It's only true in our interface because our interface, because it's compressing reality, it's giving the false impression of limits when the vast network of conscious agents is in fact infinite. So we may find that there's an aspect of evolution by natural selection that's deeply misleading. In fact, the very notion of limits and limited resources may be a deeply misleading consequence of having a necessarily finite interface. I'm going to be really interested to see that. And so that means possibly, I mean, one possible outcome is that once we learn how to hack our interface and go beyond it, we may actually open up unlimited resources. The illusion of limited resources may be revealed to be just an illusion. We may tap into effectively unbounded energy of some kind. That's going to be really interesting for me. On the other hand, there is still an aspect of your question that is poignant, and that is, I don't know about the moral realm here. Are agents necessarily nice and good? I don't know. I mean, in the sense that, and even our notion of what do we mean by good and nice and so forth may have to be completely reconceptualized. I myself have never seen a theory of morals and ethics that I think is fundamental enough. And we're going to have to, I think we'll have to dig deeper to understand what we mean by right and wrong, good and bad. I'll just give an example. I think all of our intuitions are too tied to the human condition. They're too parochial. So, for example, for us, it seems patently wrong to commit siblicide, to kill a sibling. It seems patently wrong. And I'm not going to argue that it's right. I think it feels patently wrong. It probably is wrong. But there's a bird called the blue-footed booby. The mother lays 2 eggs, and the 2 chicks, when they hatch, their first agenda item is to kill each other. And they fight to the death. One, and whichever one is stronger or more lucky, pecks the other one to death, or pecks it and puts it out in the sun and it bakes to death. The mother watches her own offspring die horribly and does nothing to stop it. She pecked her sibling to death. That's why she's a mother. And the evolutionary logic here seems to be, in the niche, the ecological niche where the blue-footed booby lives, there are enough resources to raise 1 chick successfully, but not 2. And so for the strategy then is to have 2 chicks, have them fight so that the stronger one, the one that's fitter with the better genes, gets selected so that the species will survive with the better genes. So the choice evolutionarily seems to be between siblicide and extinction. And given that choice, evolution has de facto chosen siblicide over extinction. It feels, from our human sensibilities, terribly wrong. Siblicide seems just ultimately wrong. And for us, it is wrong, but raise this question to say, I don't have a theory of morals and right and wrong. Lacking such a theory, of course, I think that we should all behave according to the law. Like, don't commit murder, don't commit suicide. That we have to do that. But admitting that does not mean that I think that I understand why I need to do that. I don't. I don't think anybody does. I am not happy with any theory of morals or ethics that we've had so far. And I won't be happy with any theory until it applies to every species. I want a theory of right and wrong that doesn't just apply to Homo sapiens. It applies to every species and helps us understand all species and gives us understanding there. So ultimately, I don't understand what right and wrong is. I have these very human-centered emotions that we can explain using evolutionary psychology principles, which is very, very different from having a principled understanding of right and wrong, or even if there is such a thing as right and wrong. Or maybe I talked about competition in evolution as perhaps being an artifact of the very fact that we have an interface, that our interface gives us the illusion of limited resources, and therefore evolution gives us the illusion of competition for limited resources. It may also be that morals are part of that whole illusion of a finite interface, that when there are limited resources, then I have to be negotiating with you and to be fair to you because we're fighting over limited resources. A lot of moral intuitions have to do with what happens when you and I both want the same thing and there's not enough to go around. And so the two may be very much limited. So your question about these other agents out there are very categories of right and wrong, of morals, may be artifacts of our interface. I don't know. They may be artifacts of the necessary limits of an interface. But on the other hand, I'll say this: when we succeed in opening up new portals into the realm of conscious agents, I don't know what to expect. It could be Pandora's box. It could be a window we wish we'd never opened. I don't a portal we wish we'd never opened. I just don't know. The best we can do is to not pretend that we know more than I think it's a pretense to think that we understand morals and right and wrong. I think that's just wrong. Science has only studied our interface. We haven't ever yet studied objective reality. Our species is, we're rookies. We're real rookies. We're just getting started. We're just beginning to learn what the tools of science can do. And we have to recognize that to move forward, we have to be willing to let go of things that we deeply hold and deeply think we knew. We thought we knew that space is fundamental. That's just wrong. We thought we knew that consciousness emerges from the brain. We're just wrong. We thought we knew what right and wrong is. Well, I'm not advocating for, libertarian and nasty behavior. I'm not advocating for that at all. I'm just saying behave properly, but we don't understand yet why we must. We don't have a deep understanding of why we need to do that. And if we must, but that's just an artifact of our interface that we must. So we must in the interface, and I wouldn't advocate, again, for murder or civilicide or being, unhospitable to people in need and things like that. I'm not advocating for that at all. And nothing that I'm saying should be interpreted that way. I'm just saying, let's not pretend we understand why we need to act that way. And we don't. And part of understanding this deeper realm of conscious agents and how it projects to our interface may ultimately give us a principled understanding of right and wrong. But we're not anywhere near it, I don't think. And we haven't even had the tools yet to think about it properly. We have to have this whole framework of the network of conscious agents, our interface, how we represent ourselves within it, and all that dynamic before we'll be in a position to even get a reasonable definition or theory of morality, or to know if maybe that's just the wrong idea. I don't know. But I'll just say, your point that when we open up new portals, we could be opening Pandora's box, I absolutely agree. But I've been talking about this other stuff just to say that there's a lot of other concepts that we'll need to understand here. Every question leads to all sorts of implications of this theory that might not be obvious.
Yeah,
it's a rabbit hole.
Yeah, it is, like, because, for example, I guess it also depends on who is opening those portals. It depends on who has the technology. If some authoritarian state that abuses its citizens, and I can think of one fairly close to me that does that, who, let's say, are leading in the research on AI, and 20 years time, let's say they actually do produce AI things that are brain interfaces that can modulate the activity of our nervous systems and open up portals of perception, then the people that would be doing that, the authoritarian dictators, are opening up portals to the conscious agents that are higher in that they are an instantiation of. And so that's a bit of a scary concept. Yeah.
I agree with you. I mean, I have nothing against ants, but their interests are not my interests, and if they get on my kitchen sink, I kill them. It's not a hostile act. They're nothing to me in some sense, right? And we have to wonder if, when we open up these portals, we'll be like ants to whatever. It's not that they're necessarily, hostile to us or anything. It's just our interests are not their interests, and if we get on their kitchen sink, well, so much the worse for us.
Yeah. So just before we wrap it up, I'd like to just touch on psychedelics as well.
Sure.
I guess it's kind of similar to what we were just talking about, but maybe future technologies will be allowing us to access information or experiences in the realm of higher conscious agents. Could it be that psychedelics are a natural way of doing that? Indigenous communities all over the world have either through, I mean, sometimes it's not even through psychedelics, it's through trance or dancing, yes, or beats, or in the Amazon it's DMT in the form of ayahuasca. In Northern Europe it was Amanita muscaria mushrooms, and other places different psychedelics. But the general theme of most indigenous communities, it goes something like, there is a spiritual realm that people call the spirit world that is just behind or in some way parallel to this world that we experience. And so maybe what they're getting at is sort of what you're describing, actually, that yes, there is a realm of consciousness just behind our usual perception, and maybe the use of psychedelics in shamanic cultures is knocking down the filters or in some way of the nervous system of the conscious agent that's experiencing that, and opening up to whatever's there beyond the space-time interface that we have. What do you think of that?
I think that that's a serious possibility, that these drugs are tools, crude. We don't understand them. We don't understand how they work. There's a lot of research to be done, but they could be tools that, in some sense, alter our interface, that loosen up this interface. I mean, once we understand how the realm of conscious agents works, that whole vast interacting network, and how our interface compresses that and simplifies it, we may find that there are simple little hacks that change that interface in fundamental ways, that open up new dimensions of understanding of that realm of conscious agents. And the way we see that within our interface is neurotransmitter-like chemicals that we can take, like DMT and so forth, that affect. And, you know, some of the, I know people who've taken trips, and there's a consistent story, like with DMT, that you meet entities that are intelligent and that are telling you things. They can be a little bit rough with you, but they're telling you things that they seem to be for your good down the road, although they might be a little bit rough now. So, I mean, one interpretation is this is all nonsense, it's just goofy illusions and so forth, but I can't dismiss the possibility from my own framework that this is a genuine, in some sense, loosening up of an interface, opening cracks, new portals. And I think that as a scientist, we should certainly, within my framework, take that possibility seriously. Try to figure out, again, this mapping from the network of conscious agents into our particular interface, to understand within that framework, what do chemicals that we call neurotransmitters correspond to in that mapping, and what is their action on neurons at the synapses and at postsynaptic receptors and so forth. What is that in our deeper theory, so that we can begin to, only then will we be able to answer your question precisely, to say, yes, DMT is, in fact, with our deep understanding of the network of conscious agents, the mapping onto our interface, how the different parts of it work, we now know what DMT does. And yes, it does, in fact, open new portals. So you can see we have a lot of work to do there. And it's work that we'll only be able to do with really serious, mathematically precise modeling of realm of conscious agents, our interface, and the mapping. There is a ton of science to do ahead. But I think it's worth doing, because I think that there's a non-trivial possibility that DMT and these psychedelic drugs may be our first hint at the technologies that will be required to open up our interface. And so I think what we'll find is they're just the first wave of insights, that they're really crude. We have very little control over them and so forth. But hey, you have to start somewhere. So I think we'll look back, a few centuries from now, when we've actually worked this all out, we'll look back and realize, well, yeah, ayahuasca, DMT, and all these things, the LSD, they were opening up. Some of them were opening up portals. Some of them were just screwing up the interface and crashing it and making it burn and do crazy stuff. So we'll have to sort that out. Some of them are just interfaces crashing and burning and falling apart. Others are opening up, and we'll have to figure out which ones are opening up into the new portals and which ones are just, you screwed that one up. You crashed. You essentially crashed the system. Well, that's not helpful. So we'll find out which ones are crashing the system and which ones are opening it up. But I think that some of them may be genuine opening up of new portals. And I'm all for that. But you can see the level of sophistication that's going to be required to answer these questions. What we have to do, we have to get a mathematical model of conscious agents. There's going to be a lot of debugging for that model, a lot of work ahead. A mathematically precise mapping onto our space-time interface with Homo sapiens, including detailed mapping, what in conscious agents corresponds to space-time, what to quantum fields, what to molecules, protons, neutrons, what to neurons. All the mapping has to be mapped out in all the dynamics. And then we can start to try to answer the kinds of questions you're asking. So in other words, science hasn't even gotten to 0.1% of what it needs to do. We haven't even really broached the hard work yet. And what we've done is the work has been heroic, it's been spectacular, brilliant, and we're not even really at the starting line yet for what science needs to do. We haven't even really gotten a theory of reality and understood space and time as an interface, gotten that mapping. That's the real work ahead for science. And then, I wish, I'm so eager to see what happens. So I wish I could stick around to see, but only then will we be able to answer your question in some detail. I'm looking forward to as much as we can see. We know so little. We have so much to do.
Yeah, I think that one's a really interesting one for me, because there's just something that it really, the experiences that people talk about when they use psychedelics really map onto what you're saying. I think they go together very, very well, because you're talking about, there's a deeper realm of basically infinite sentience.
Yes.
That is organized into self-referencing systems that you call agents or conscious agents, or you could say entities or whatever they are.
Right.
And of course, this is what people describe. They take off, sort of like taking off the VR goggles and going, whoa, okay, that's what reality is. And then 10 minutes later, the VR goggles are back on, and they're sort of trying to make sense of it within the VR goggle reference frame. And
I agree.
Yeah, it's really bizarre. Like, you could just spend 10 minutes on one of these forums online reading through some of these experience reports, and it's like, whoa, it's really almost arrogant to just dismiss it as, it's just a hallucination. It's like, well, right. We don't know what hallucination is because we don't know what consciousness is. No one has, like you were saying, no one has a definite theory of what consciousness is at all. So how can we say what's hallucination and what's not? Anil says everything's a hallucination. So
I agree with you. And from a physicalist framework, of course, consciousness is just an epiphenomenon. It's not fundamental. It's not part of ultimate reality. And so, in some sense, it probably is just epiphenomenal. Of course, there are no entities out there, and this is all hallucination, and it's not an insight into reality. Within my framework, it opens up the possibility that this is a real insight. I mean, as I said, it's also possible that we're just crashing the interface and so forth. We'll see. But I absolutely agree that it means that we could be opening up, crudely, new portals. And one last point I would like to make before we quit is one natural question about this realm of conscious agents is why? What is it about? What's it for? Why is there consciousness as opposed to nothing? Why is there something rather than nothing? And what is consciousness up to? And why is it up to that? And we're going to have to answer those questions, because if we want a true dynamics of consciousness, the dynamics is going to have to explain. It'll have to embody our understanding of what this is all about and what's consciousness up to. And I don't know. But the ideas I'll just say two directions I'm pursuing, and then we probably should close. One is Gödel's theorem. Gödel's incompleteness theorem says that no axiomatic system can prove all the truths. There are always undecidable statements. And what it effectively means that from just the structure of mathematics itself, our universe has unbounded potential for infinite exploration. And we can never come to the end of it. There's infinite exploration. Gödel's theorem is hinting that in the very structure of mathematics, and by the way, mathematics isn't divorced from consciousness. When I write down, every conscious experience has a structure, and structure is mathematics. And so when I say consciousness is fundamental, mathematical structure is fundamental because consciousness cannot be divorced from structure. It's a really interesting aspect of it. And that would be a whole other hour to go into that. But my work in psychophysics is all about studying the structure of conscious experience, the mathematical structure all over the place. The reason we can make virtual reality that's so effective is because we've understood enough of the mathematics of consciousness that we can trick you into creating the virtual worlds we want. We can do it with mathematical precision because consciousness actually follows mathematically precise rules. That's why we can have a science of consciousness. So Gödel's theorem is telling us that there's something very, very deep about the nature of reality, that it can't be grasped. There's infinite exploration. There's always going to be possible no matter how much you explore. Maybe that's what consciousness is about. Consciousness is not divorced from structure. It is structured, and it's exploring itself by exploring structure. And that's an endless exploration. That's one possibility. I don't know. That's one possibility. But what we're going to have to do is propose principles like that as the fundamental dynamical rules, and also for the existence, the reason for existence, right? So maybe Gödel's theorem is the ultimate deep reason for the existence of consciousness that's endlessly exploring, because consciousness is not divorced from mathematics, and mathematics is necessarily open-ended investigation and exploration. If I'm wrong about that, I mean, that's just a long shot. But it gives you the flavor of how deep an idea we're going to have. I mean, this is not going to be a trivial thing. And Gödel's theorem is one of the deepest results ever. And so we may need to dig that deep or deeper to understand what it's about. But if we don't get it that way, then here's what we're going to have to do. We're going to have to say, okay, let's just propose something like maybe conscious agents just interact to increase mutual information, which is a technical term. So we're going to have conscious agents that hill climb mutual information. We'll project that into our user interface and see what it looks like. If it looks like something that matches evolution with natural selection and quantum theory and general relativity, hey, then maybe we're on the right track. But if that doesn't look like what we're seeing in our interface, well, that's probably the wrong principle. Let's try another principle. So we're going to have some hard work to figure out what it's about. What is consciousness up to? What is it about? Maybe there'll be some deep insight like Gödel's theorem that just breaks the whole thing open and hey, we're good. Or if not, then we'll just have to do it like the pedestrian way. Let's try this dynamics. I don't know why it would be that way, but let's just try it. And then we'll project it back on our interface. If it gives back the scientific theories, evolution, quantum field theory, and general, the stuff that we know and love, then we're onto something. If it doesn't, well, okay, let's try a different dynamic. So either we're going to have to do it one way. Maybe we're too stupid to get it from the deep insight. We may just have to try, like Edison said, well, let's try this filament for a light bulb. Well, that doesn't work. Okay, let's try this one. And after you try a few hundred and you go, whoa, here's the one that works, right? I'm not brilliant. I just tried everything until I found one that worked. And maybe we'll get the principle of conscious dynamics that way. So I don't know what consciousness is about. It may be about Gödel's theorem. I don't know, but we have a lot of fun ahead. We have the hope of actually figuring out what is this whole show about and why. I can't wait.
Yeah. I think that's the sort of fundamental question that everyone wants to know, really. I think that's probably what when people say, oh, I wonder what what's life all about? They're not really talking about what the unconscious processes of life are about. They're talking about what is their conscious experience and why they're having it, you know?
Right.
So I think,
Right.
yeah. So
It's a
yeah,
pretty
yeah,
elaborate game. What's the game about?
yeah. Just like you said, it might be just to, yeah, just consciousness exploring
Exploring.
its infinite possibilities. Maybe.
That's
I
the
don't know.
best idea I've got so far.
Kind of a nice idea.
Yeah, yeah.
Okay. Well, thank you so much for, yeah, taking 2.5 hours now. Yeah.
Oh, my pleasure.
That's really, really interesting.
Great to talk with you, John, and good luck with your podcasts.